Okay, so let's move on. JPA Advanced. So the advanced topics that we are going to cover in this presentation and hands-on lab, including embeddable object, secondary tables, composite primary key, sometimes it's called compound primary key, fetch mode, eager or lazy fetching, and entity listeners. So let's talk about embeddable object. What is an embeddable object? It's pretty straightforward concept. Embeddable object is stored as part of an owning entity, so it doesn't have its own identity. So it's not an entity itself, and it doesn't have its own identity. Now, because it doesn't have any identity, the fields of embeddable object is mapped into the same table of the owning entity. So all the fields of embeddable class will be in the same table of owning entity. So two annotations are going to be used here. So embeddable class itself is going to be annotated with embeddable, and in the owning entity you're going to use embedded annotation to annotate the field for the embeddable class. So let's see an example code. So let's say customer is an owning entity. So it's an entity and it is owning entity of this embeddable class called customer info. So under here, customer info class is annotated with embeddable, and you can see it has three fields, and you can see it doesn't have its own ID. So we have a name, credit, and photo fields in the embeddable class. Now, owning class, in this case customer, has customer info field with embedded annotation. So the table that gets created will be something like this. So the table for this owning entity will include not only the fields of itself, but also the fields of embedded, in this case, customer info fields, the fields of customer info class. So you can see name, credit, and photo are in the same table of customer table. Okay, so let's do our first demo. So for those of you who have an access to the hands-on lab, you can just try these things together with me. I have posted the hands-on lab to the class website a couple of days ago, so you should be able to download it and open the project, and you should be able to do the same thing I do here. First of all, you have to start the database. So you have to start the JavaDB database with the start server, and assuming you have testDB table or testDB the database, you should be able to do the same thing I do here. So the first demo is embeddable. So let's run the application first. Run the application, and you can see this is owning table. My own employee table contains ID and my name from the employee class, and oh, actually my salary too, and city and street and states. These informations are from embeddable the class of address. So let's take a look at the code. So we have employee entity class, which is owning class. So you can see entity, and we are going to name the table as my own employee table, and it has ID field and name, which is going to be mapped to my name column, and salary field that is mapped to my salary column, and then it has address field with embedded annotation. And if you see address class, let me go to the source, and you can see address class is annotated with embeddable. So in this case, the fields of address class, street, city, and states are going to be in the same table of the employee table. So let's actually see the code, the result one more time. So if you see expand this output, you can see basically we added 3 employees, and these 2 employees has in fact created with address information. So if you take a look at the main .java, and here we have created employee with address. The first 2 employees are created with the address field set, and third employee is set without the address. That's the reason third employee doesn't see information on address fields. Okay, so hopefully that is straightforward. Secondary tables. So JPA allows multiple tables to be assigned to a single table. So in that case, you're going to use secondary table and secondary tables annotations. Now, secondary tables could be useful when you're trying to map existing tables to entity class. So for example, you have an entity class and you happen to have existing tables that contains information on some fields. That's where secondary tables could be useful. So in this case, we have employee entity class. Now, instead of having everything in employee table, you are going to have 2 other tables in this case, salary table and whatever table. So you have secondary tables, and then you have secondary table 1 and secondary table 2. So the way that you are going to specify which fields are going to go, let me repeat. The way that you are going to specify which fields of this entity class will be in the secondary table, you are going to specify table attribute for that column. So in this case, the salary column, in this case, my salary column, will be in a separate table called salary. Okay? All right, that's secondary table. So let's do the demo. So let's take a look at the code first, and then we are going to run the application. So secondary table. So let's take a look at the entity classes. We have employee entity class, and here we have defined 2 secondary table. So we are going to have 3 tables: my own employee table, and salary table, and a table. So for the fields that you're going to have in the secondary tables are this column. So here for salary column, so in the column name is going to be my salary, will be in salary table. Okay, so let's run the application. Okay, so here, so we have my own employee table, and then we have a salary table, and you can see salary table, my salary column is in separate table called the salary. Even though we have created a table, I didn't print it out here because we don't have any fields in a table, but it should have been created. So if you take a look at the services, and if you have already made a connection, and here tables, let me just refresh it, and you can see we have 3 tables: my own employee table, salary table, and a table. So if you actually see the contents of salary, you should see a few items because we have created 3 employee object instances in the main code. Okay. Okay, so I said view data. Oh, here they go. Okay. Okay, so we have 3 entries. Okay, so let's move on to the next. Now, before we move on, let me try to answer a few questions. Okay, first question from Bala. In what situations we use embedded or embeddable annotations? Well, there could be some cases that you want to capture some fields in a separate class. Okay, so instead of the same class, I mean it's a more or less in a sense structural packaging issue. I mean if you happen to have 100 fields in employee entity class, you don't want to have a table of 100 columns, right? So in that case, you might in fact have the embeddable class that actually captures something that are related, like address. Address embeddable class has street and city and state, and they are related in address. You want to actually capture as a separate class. So it's actually done more or less from encapsulation reason. Okay, so let me see the next question. Where can we use this concept? You have to be more specific on your question when you say, yes, okay, so concept of secondary table. So as I said before, the secondary table could be useful when you're trying to map several existing tables into your single entity class. Okay, all right, moving forward. Composite primary keys, or some people call compound primary keys. So when you want to have an entity that has identifier, meaning ID field, that is composed of multiple fields, this is where you can use a composite primary key. So primary key of the table is made of multiple columns. And in this case, the primary key class needs to be defined, and it has to be also serializable type as well. Now there are two different ways that you can have composite primary key class. So the option one is you're going to use embeddable class, and then we are going to use embedded ID the annotation in the owning class, owning entity class. And option two is that you're going to use ID class annotation. So let's take a look at these two options using the hands-on lab, but I think we have a code for the first option. So this is again pretty simple to use. Again, something very similar to embeddable and embedded annotation case we have seen in the beginning of this presentation. So let's say we have employee entity class, and employee entity class wants to use fields defined in employee ID class as a primary key. In that case, you're going to use embedded ID annotation using embedded ID, in this case, employee ID class. Okay, and if you take a look at the employee ID, it is embeddable type. Okay, so let's do the demo. So we're going to take a look at the example of embedded ID, and then we are going to take a look at the ID class option. Okay, so embeddable ID. So let's take a look at the code first. We are going to take a look at the employee entity class. So here is using embedded ID annotation to indicate that the class of employee ID will be used as a primary key, meaning the fields of employee ID will be used as a primary key of employee entity. So let's take a look at the employee ID source code. So employee ID, in this case, source code, employee ID class is annotated with embeddable. So in this case, the department and state, okay, the fields in employee ID class will be used. The combination of department state will be used as a primary key of the employee entity. Okay, so let's take a look at the code. Let's run the application. So as you can see, employee table has department and state columns as a primary keys, meaning the combination of these two will be primary key. So if you take a look at the main code, so we have added basically this is going to be primary key, and then these are the information on the employee fields. Okay, now if you try to actually add the same one, then because this is used as a primary key, you will actually have an exception, that like a duplicate key exception. Okay. All right, so that is the case where we are using embedded ID annotation in the owning entity to specify embedded ID. In this case, the class that is actually annotated with embeddable is used as primary key composite class. Now let's take a look at the second option. So in this case, we are using ID class annotation. So let's take a look at the code. So if you take a look at the employee class, so we have employee class, and it's using ID class annotation. Okay, and so it's basically again using the fields of employee ID class as a primary key. Now if you take a look at the employee ID class, this is not annotated with it. This is not annotated with anything. Okay, so it's not annotated with embeddable. Okay, so again, this one is department and state, but in the employee class, basically you are going to specify each of those fields of, in this case, employee ID class with ID annotation. Okay, so you can pick and choose a subset, in fact, of employee ID class to specify that the combination of these, any fields annotated with ID annotation, meaning any fields of this class annotated with ID class, will be used as a primary key, composite primary key. Okay, so if you run the application, the result is going to be pretty much the same. So we'll see employee table that uses department and state as composite primary key for this employee table. Okay, so let's move on to the next. Fetch mode. Yeah, we touched upon this fetch mode in Hibernate extensively, so I assume most of you have some idea on what fetch mode is all about. So, So just like you expected, we have eager and lazy fetch mode. So eager means the data will be immediately loaded. Lazy means it will load the data only when it is needed. Now the default in JPA is that eager is default for one-to-one relationship, and for one-to-many and many-to-many relationships, lazy is the default. So lazy fetch benefit large objects. So if you have a relationship of one-to-many with a large object, of collection of large objects, then obviously you know it could benefit because it will be loaded only when it is accessed. Okay, so let's do the demo. So we are going to try the eager mode first, and then we are going to do lazy mode. Okay, and in this case, it's going to be one-to-many relationship. So let's take a look at the code. So we are going to try eager mode, and if you see the entity relationship, we have manufacturer Java, which has, So this is a manufacturer entity, and it has one-to-many relationship with product. Okay, now you can see in one-to-many relationship with product, you are using eager fetch mode. Okay, what that means is that it's going to, when an object of manufacturer entity object is loaded, the production collection will be also loaded because you specify eager. Okay, and we have another one-to-many relationship somewhere, I think. Okay, maybe that's only one-to-many relationship in this case. Okay, so, and we have a product. Okay, and it should specify many-to-one relationship with manufacturer. Okay. Oh, okay. So this one also has a many-to-one relationship with the product code. Okay. Alright, so in our main application, we are basically we are going to load just one manufacturer object. Okay, we just perform find operation of this ID, and just to make sure, you know, the what is being executed between these two, as the println statement is made. So before calling enfind and after calling enfind. So we'll see how many statements are being executed between before and after. Okay, so let's try to let's run the eager fetch mode first. Okay, so let's take a look at the code. So you can see I enabled. So in this case, I enabled the logging. So I enabled logging level to find, so we can see you know, select statement or whatever SQL statement that are being performed in this case. Okay, so which one? Oh, this is the one. So let's just maximize it. So here you see before calling enfind and after calling enfind. So you can see it actually perform select on manufacturer. So it gets the manufacturer, and then it actually gets the product information as well. Okay, so you can see because it is set as eager mode, meaning between manufacturer and product, the one-to-many relationship is set with the eager fetch mode. You can see this is also being fetched when manufacturer object is loaded. Okay, now let's try let's try the lazy mode. So this is a lazy mode, and if you take a look at the entity class, so if you see manufacturer, and in the one-to-many relationship, you will see, let me maximize it, sorry about that. So now we are using fetch mode of lazy, okay, meaning until this product collection is accessed in your application, it will not be loaded. Okay, so let's run this application. So this is lazy application. Run the application. So now you can see before and after is going to just load. It just performed the select statement on manufacturer. It doesn't load product because we haven't accessed the product. Okay, so you can see the difference, right? All right. Let's move on to the next, which is event listener, which is the last topic of this presentation. Event listeners, the entity listeners, you can think of these listeners as a callback methods, are called at various stages of entity lifecycle. So these callback methods could be specified with this annotation, pre-persist and post-persist. So whatever callback method that you annotated with pre-persist will be called before persist operation is executed. Any method that is annotated with a post-persist annotation will be called after persist. And this is for remove, and this is for update, and this is after loading. So you can specify these callback methods with this annotation right in the entity class, or you can put them in a separate listener class. So we'll see examples of both. So we have account bean entity class. Now we have defined a separate class called alert monitor as entity listener. Okay, so inside this class you can have method with those the event listener callback annotations. So examples are the example on the next slide. This is a case that you are specifying this callback method right in the entity class. So in this case, this validate create method will be invoked before you are performing a persistence operation for this particular entity object. Post load is after loading, you are performing the logic inside this method. So in this case, before you actually creating an account, you want to check whether get balance. Balance is the non-negative. Okay, so you can actually throw an exception if that validation check is turned out to be false. Okay, post load. So here you find out if the account is preferred customer or not. So based on after you load a particular account, you can find out whether that account is preferred status or not, and you can set the flag. Okay, so this is a case that you are setting callback methods with this annotation right in the entity class. Oops, sorry. This is an example. We are specifying methods with this annotation in a separate class. So as you remember in this first entity class definition here, we specify that this the alert monitor class is a separate class where these callback methods are provided with annotations. Okay, so let's do our last demo. This is entity listener. So listener. So let's see the code. So we have provided callback methods right in the entity class, in this case employee class. Okay, sorry about that. So here we have entity class, and we have pre-persist callback method and post load callback method. So we are basically just displaying some information. So we say validate create is called, and my post load is called. Okay, and then we also have a separate class called alert monitor class. Okay, so if you take a look at the alert monitor class is on the listeners package. Okay, so let's take a look at the alert monitor, and it has again very simple method called the validate create, and it has this annotation pre-persist. So we have in fact the method in alert monitor separate class that display things when things get persist, and also in employee class. Okay, so if you take a look at the main Java, we are basically creating 3 employee objects. So we are going to see 3 plus 3 logging message, because we have the entity listener pre-persist entity listener callback method right in the employee class as well as alert monitor class. Okay, so let's run this application. Okay, I have to actually delete the files. I have to clean up the files. Okay, so let me just delete these files. Now I have to delete this one first. And I will delete and delete this one. Okay, so now we are going to run the application. Okay, so let's expand this guy. So you can see we have a method called from alert monitor. So we are going to see, as I said before, 6 logging message, system out println message. One is from alert monitor, the other one is from employee entity class, and we created 3 employee object. Okay, so we created 3 employee object. Okay. Okay, so I hope things are relatively clear. Again, I strongly recommend to download the hands-on app and play around these things. Okay. Alright, so that is the end of the presentation, and let me just finish